Hello! Today I'm starting a challenge to create an AI that can play Hollow Knight in 1 week. In my recent project, a friend and I built a model that can recognize actions in unlabeled online videos of Hollow Knight. This was inspired by OpenAI's inverse dynamic model, where they train an AI to play Minecraft. Now that I feel confident in my knowledge, I decided to challenge myself by creating an agent that can play Hollow Knight. So let's begin with some considerations. The goal is for the agent to defeat Hornet without using any charms, which I believe is a great introductory battle. I'll be using supervised learning, and in particular behavioral cloning approach, because I found this video where it already implemented an AI with reinforcement learning. The agent will be able to perform basic actions: move left, move right, attack, jump, dash, throw a spell, and focus. And the last consideration is that the AI should not use any information that wouldn't be available to a human player, such as hitboxes, colliders, or similar data. Day 1. I created a custom Hollow Knight mod in C# that samples the games at 20 frames per second and sends gameplay screenshots to the actuator. The actuator will be the program that processes frames, makes predictions, and applies actions into the game. This actuator will run as a separate Python process, communicating with the game via Windows pipe. Next, I develop the actuator itself. It receives, rescales, and stores frames in a queue. The window of frames is processed by the model, which then makes predictions and applies actions using PyAutoGUI. To test the system, I needed a small label dataset. I recorded 10 minutes of Hornet battles using a custom mod I made in my past project. It lets you record gameplay and actions while playing. Then, I used this initial dataset to train the model. The architecture is detailed in the GitHub repository found in the description, but in short, it uses a ResNet 18 model to extract spatial features from the frames, followed by an LSTM to capture temporal features. Finally, a fully connected layer makes the final predictions using multi-label classification. After some debugging, I tested the first trained model. It seemed to learn movement well, following Hornet and occasionally hitting her. It looks promising. Day 2. I noticed that there was some delay in the agent's actions because the processing pipeline was too slow, causing frames to accumulate in memory. To optimize this, I made sure each frame was processed by the ResNet model as soon as it was received, generating the embedding vectors for each frame. When making predictions, I only needed to provide the LSTM and predictor layer with the embedding vectors in the window. The next optimization was to create a separate thread for pressing keys. I switched from PyAutoGUI to using the keyboard library, which seemed to work faster. Day 3. With the processing pipeline working in real time, I recorded almost 2 hours of gameplay, created datasets, and trained multiple models with different hyperparameters configurations. Day 4. I tested the different trained models and found one that performed well attacking and moving, but did struggle with dodging. I thought this might be because I was using a 3-frame window, which might be too short. So I trained a new model with a 5-frame window. This took all day because I had to reduce the batch size to fit the windows on my GPU. Unfortunately, the results were very similar, so I decided to continue with the previous model. Day 5. As the training was done using full gameplay videos, some actions were less common than others. To fix this, I made a balanced dataset to adjust the model and make non-movement actions happen more often. After testing it in-game, the model's performance was more consistent, but it lost a little bit of the human-like behavior it used to have. Day 6 and 7. I spent these 2 days trying to fine-tune the model against the Mantis Lords, so I recorded a few fights and retrained the model. It learned to dodge certain attacks, and I think more data would improve its performance, but I conclude the challenge here because training times were quite long and I really wanted to use my PC again. And here is the final gameplay result from the agent obtained on day 5. I'm really happy with the outcome. If you have any question or want to see another idea, feel free to leave a comment below. Thanks for watching.